this last video for chapter 12, I'm hopefully going to convince you that correlation do not prove causation. And this is also something when you're working on your literature review or for your final paper or making revisions, is think about when you're discussing one of those papers you read, was it an experiment? Did they manipulate something? If they manipulated something, they can suggest a cause and effect relationship, and there is no correlation there. If they were looking at the strength of two variables, perhaps using surveys, descriptive types of techniques, and they looked at the strength of a relationship, that's a true correlation. So watch when you use those words, a correlation or an association, and make sure that you're not talking about a true experiment. However, important to remember that correlations do not prove causation. So this is just kind of a funny little meme. The top map shows mysterious cases of people vanishing without a trace. So here's just marking all the places where people have vanished without a trace. And down here, it shows you the largest cave system. So suggesting perhaps people vanish because they're in a cave. I found some funny ones this last week too about COVID-19, but I couldn't get the proper images to put into the video. None of them were clear enough. So it's again important to remember that correlation describes a relationship but does not demonstrate causation. And one of those things we mentioned at the very end of that last video is because of the third variable problem. So just because two variables are related doesn't mean that one causes the other. For example, in the UK, you could find a correlation between coastal air pollution and ice cream sales. So as ice cream sales increase, coastal air pollution in the UK increases. Does that mean that ice cream sales cause air pollution? No. What do you think? What could be a confounding variable? What could be? There's many third variables. Well, what just kind of jumps out at you? What's another time when perhaps you eat ice cream and then people are driving to the coast, which increases the pollution? Warm weather. So this warm weather here is a third variable. And you can't rule out that third variable. That's what causes this third variable problem. So how does an experiment control for this third variable problem? It manipulates the variables and it controls for extraneous variables. And so that's why that control that an experiment has allows us to determine cause and effect, but a correlational study does not. We also have a directionality problem with correlations. Just because two variables are related, again, doesn't mean that one causes the other, because we don't know which one came first. For example, there's a correlation between the number of hours viewing violence and aggression on TV and aggressive behavior at home and in school. So you might think then that the watching violent TV program causes that violent behavior. But is it also possible that people who are already naturally aggressive tend to like watching aggressive TV programs more? We don't know which came first. It's kind of the chicken or the egg, question, right? Did the aggressive TV watching cause the aggressive behavior, or did the aggressive behavior make them want to watch more aggressive TV programs? So again, we don't know with a correlation which one came first, whereas in an experiment, we're manipulating those variables. So we know we have this manipulation, and we're looking at and measuring the response afterwards. So how does an experiment control for the directionality problem? By manipulating that independent variable. So we have one group that watches TV. We have another group who doesn't watch TV. And then we measure their aggressive behavior. So we're manipulating who watches the aggressive TV programming and controlling and making sure there's a group that does not. And then we can look at aggressive behavior and make a determination about cause and effect relationships.